Welcome, everyone, and thank you for attending our session. We're going to talk about building an operational technology, cybersecurity capability for your company. Although we are employees at Amtrak, much of what we're going to discuss is applicable to other industrial sectors. And as the title suggests, this is a field guide based on our observations in starting OT cyber capabilities for organizations over the years. And before we get started, by show of hands, how many of you already have a dedicated OT cyber capability? It might be rare, yeah, okay. And how many of you picked up OT cybersecurity duties, but your primary job is in IT? Okay, yeah, a little bit more. And then, how many of you are not doing any OT cybersecurity capability at all? Any cybersecurity, okay, yeah. So it's not unusual to see these kinds of numbers, and there's a survey out there recently that says that 15% of the CISOs say they have responsibility for OT security within their organization. So there's still this is an area where there's still a lot of opportunity for conversation. So let's start with a simple definition of OT, and we're going to use the Gartner definition here, and it says that operational technology is hardware or software that detects or causes a change through the direct monitoring and or control of industrial equipment, assets, processes, and events. It provides power, water, and gas to our homes and enables a safe transportation of passengers, whether you're on a train, plane, or an automobile. There's going to be more of this, and according to one report, it suggests that the global industrial automation and control system market is looking at a compound annual growth rate of about around 10% over the next 7 years. So how do you know if you need this capability? Well, generally, if you rely on industrial digital equipment to heat something, cool something, or move something, you should probably take a look into it. And if you don't own any of these things, do you depend on a supply chain that consists and relies on operational technology? So we need to think about these things. So by the end of this session, I hope to leave you with a couple takeaways. One is how to start building this capability and just lay out some of the obstacles that you'll face and how to overcome some of those things. So John and I will be sharing the stage here, and I'll turn it over to John.
Okay, well, good afternoon, everyone. So, building an OT cybersecurity program, if you kind of visualize it, right, you can think of it, standing at the top of a ski slope, right? There are many trails of varying difficulty to get to the bottom, but any of those paths will eventually take you there. So, you have choices, right? If you choose maybe a more risky path or difficult path, you may get there faster, but you may need more experience or resources to do it successfully. Taking an easier path, it'll take longer to get there, but you can navigate that path a little more cautiously. Take your time and do deliberate planning. But no matter the path you take, you're going to run into challenges and obstacles along the way. And so the point is that there's more than one way to build an OT cybersecurity program. So, if we look across the different industries, for operational technology, right, the different critical infrastructures, I think we find some things that are common across all of them, right? Generally, there is a strong emphasis on safety culture, a focus on availability and reliability for these systems. And when we compare them to, our traditional IT systems, there's some obvious differences and some gray areas. So I think we all know, hopefully at this point, right, that scanning and patching within OT environments is a very different exercise than doing it on the IT side. And I think what you'll also find is that, within our OT environments, we're starting to see a lot more IT-type equipment showing up within those environments. And then we're also starting to see OT equipment either connected to business networks or even connected to the cloud at this point. So it's not unusual to find perhaps in your OT environment, your engineers or your operators having to administer or maintain traditional IT systems, which is not generally what they're trained for, right? So that can introduce some risk there. And so if we take a look at some of the challenges for both OT and cyber, we'll start over on the OT side. So a lot of whether it's a plant, a facility, or a process, right? Generally, what you're going to find is that there's a small crew that runs these processes. And that crew may be responsible for multiple sites, multiple facilities across different geographical areas. And generally what we found is they have little to no cybersecurity training, right? If you're lucky, maybe there's some company cyber awareness training that they do annually. Maybe your company does some phishing exercises every once in a while. But what we found is a lot of times they don't have the cyber knowledge or training to understand how certain cyber attacks can impact those systems that they work or operate on. So for documentation, if you have a new fielded system, chances are you have pretty good documentation. If it's a legacy system, there may be little to no documentation on it, or that knowledge is available, but it only exists in Bob's head, who's been working there for 20 years, right? And so, having those conversations with those operators and maintainers is crucial to understand what the system is actually doing. The next one, minimal cyber technology, right? I think this is something that's actually been changing over the last couple of years, right? 5 years ago, over the last 5 years, there's a lot of vendors and companies that have invested in this space. And so while it's still not on par with what's available on the IT side, I think that's something that's changing over the next couple of years, and we'll get a little bit closer there. But we don't have all the same tools that are available to us on the IT side as we do on the OT side. And then, as several, I think, speakers have discussed this week, right, the increasing threat to OT systems, right? This is something that has been increasing year over year for several years, and it's a trend that, frankly, is going to continue. So this is a problem that's not going away. And then because of that, that has led to increased regulatory requirements, right? So just real quick, do we have anybody in here from pipeline, oil and gas? So over the last couple of years, right, TSA has released some regulations concerning specifically pipeline and surface transportation, right? So if you're in an industry outside of that and you're not affected yet, there's a chance you could be in the future. On the cyber side, depending on what reports you read, we have a talent shortage, right? Anywhere from a couple 100,000 positions to maybe over 1 million positions that are vacant right now. To compound that issue, right, when we're talking operational technology, not only do we need to find cybersecurity professionals that understand cybersecurity, but we also need them to understand our operational technology, right? The process, the protocols, the systems that are involved in those things, because there is a difference. Policies, so some organizations, OT-specific policy doesn't exist at all. Some organizations, they may be trying to apply their IT enterprise policies to their OT environments, right? In either of those two scenarios, you're not going to get what you want out of that policy, right? So you have to really have, purpose-designed policy for your OT environments that works within your system. And then again, the IT side's no different, right? Cyber threats increasing for both IT and OT, and that regulation will also trickle over into that as well. So where do you start? All right, well, believe it or not, there actually is a lot of information published on OT cybersecurity or frameworks or regulatory requirements. So we have, starting at the bottom, we have our more general ones like NIST or IEC 62443. And then as we go up the stack, we have more industry-specific ones. Probably the one everyone's most familiar with would be something like NERC-CIP over on the energy side, right? But each, critical infrastructure vertical will have its own requirements. And so when you're trying to design these things, get familiar with the regulations that apply to your sector. And then as you design your program, right, you want to try to at least align it vertically, right? So if you can align vertically within your industry across those different regulatory requirements, it will certainly make your life a lot easier. And so also, it's not necessarily unusual to have, multiple different regulatory requirements applying to your industry. So, instead of just one thing, there might be 2 or 3 or more. So a couple takeaways here. Even within your industry, like I said, so, probably the IT side equivalent would be like PCI or HIPAA required stuff, right? Those are segments of your IT network that require additional security controls for those particular data sets, right? Same thing on the OT side. There may be portions of your business or your process that are going to require different requirements or standards than, the rest of your environment does. It used to be that some OT standards were primarily physical-based, but now, there's a lot more additional cybersecurity requirements that have been tacked onto those. So number 3, I think, is very important, having a voice in the discussion process. So if anybody was here around when TSA released that first security directive for pipeline, it was a rough go, right? The good news is that TSA was receptive to industry feedback, and they improved their processes going forward. So by the time it came around to surface transportation, they were actively working with the industry and soliciting feedback to try to draft regulation that could actually be complied with. So still some disagreements, but we're on the right path. So my advice, right, is engage often and early with your federal counterparts that regulate your industry and have a voice in that process, because if you don't, you will be left with something that you probably will not like. And then lastly, right, because of the regulation or maybe because of some incident that's happened to your environment, right, if you didn't have policy, there may be a rush to develop policy to cover that area because it's a gap, right? Don't rush to failure. You know, if you try to go too fast or you try to apply IT policy, what you're going to end up with is a policy that has so many exceptions that it's not worth the paper it's printed on, or you're going to have policy that can't or won't be complied with, right? So taking the time and doing it right is a big step to getting to where you want to go. So this kind of pathway here, really there's kind of 4 areas that we've broken stuff up to, and this is a process that we used to try to develop, you know, OT cybersecurity programs. And so, you know, this is something that you can do with initially small staff, right, and minimal resourcing, right? But you're going to have to depend heavily on your, you know, maybe your traditional IT shop initially, or your physical security shop, or your business units to assist with the development. But over time, you'll be able to build capability and capacity where you can have an organic program that exists within your organization. And so the first stage up there is the disposition phase, right? The discovery phase. So this is really like you can't defend what you don't know that you have, right? So this is a discovery process that can be done through assessments, architectural reviews, you know, incident response planning. But this is where you discover your environment so that you know what's going on within it. Once you've discovered what's in your environment, then you can take a look and determine, you know, what are your issues or your risks, right? And then you can prioritize those issues and risks in a way that you can actually start implementing, you know, things against them, which leads us to policy and equipping, right? This is kind of the area that after you've identified your risks and you've prioritized where they fall in the scheme, then you can start, you know, discovering, you know, how can you address these risks, right? So maybe it's policy, maybe it's procedures, maybe it's technology, maybe it's people, but this is where you develop those controls. And then lastly, you know, as they get rolled out, it's the testing, the tooling, and the baselining, right? So, you know, as we know, anything that goes into an operational environment needs to be thoroughly tested before it gets put into production. So it's, you know, developing the testing capabilities and processes, it's, you know, selecting the right tooling, and then developing your baselines that you can apply across your environment. So I'll turn that over to Charles next.
So when we discuss discovery in this stage, we're looking at a few discovery methods that we already do, and we're looking for additional insight into them. And so the most obvious form of discovery is through assessments. Effective discovery is not just about running scans, it's about observing your surroundings and asking questions. And so when you do this, you observe a lot of things, additional assets that were not part of any diagrams or discussions. You may also see the actual run books that the control operators use to handle different kinds of operational events. And in some cases, unfortunately, rogue connections. So the key here, though, is to build rapport with the OT staff and focus on systemic problems across all the sites. And so in this way, you can identify opportunities for enterprise investment instead of one-off solutions. This is also an opportunity to train and deputize OT staff on security concepts, because if you don't have security event monitoring tools in their environment, you're going to be relying largely on the human element. Another type of discovery is through architecture review. And if any of you have prepared for an assessment on an OT architecture, you're lucky to get a diagram at all, right? And if you do get such a diagram, you may not understand what you're looking at, and you could be wondering which end is up, is in this illusion by MC Escher. So here's some things you should be aware of. Accuracy. You want to understand that the diagrams you get may likely be inaccurate. You have to deal with unfamiliar formats, and that maybe you don't get a network diagram, but you get a one-line or a block diagram. And when you consider risk, you need to consider some of the multi-dimensions in it, in that you may need to take a look at the mechanical, pneumatic controls that also provide those additional layers of protection. And also, you want to take a look at your blind spots and recognize them, right? Verify how your organization conducts IT security architecture design reviews, and ask some of these questions, right? Do they look at how OT systems are connected? Or do they only get involved when it involves corporate connectivity? So you do want to recognize that, because that could represent a significant gap. Another method of discovery is through incident response, where there's two parts of this, proactive and reactive. And much of the discovery is centered around how and when certain departments will cluster together to respond to an event. On the proactive side, doing incident response planning with OT is a constructive exercise. If you attended some of these sessions earlier, we keep reemphasizing that. Doing this will reveal certain gaps in your current incident response plan and who the stakeholders are in a specific event and what their role is in the triage and handling of an event. On the reactive side, this is the least preferred method of discovery where you're being called in for an incident or an investigation. But you'll get a chance to observe the realities of OT's business continuity and resilience processes. And in this method, you'll learn a few things, right? Who is actually talking to who in OT, what run books are actually being used on the desk, and who the actual field people are who is responding to the equipment. These interactions are going to help you, build out those incident response plans and supporting checklists. And so other couple areas to take note as you perform this discovery, we typically put in command and control type of components in our incident response plans, but what is always lacking is what does that engineer actually do in the procedure? What's that checklist, right? So consider that, and also if there are physical security incidents that happen at some of these sites, if there are network accessible equipment, you might want to also trigger a cyber investigation on that, and I think that's also a piece that is lacking. So the third method of discovery is learning more about your own company and operations and visiting the sites you protect. Don't solely depend on cyber threat intelligence. It's a great tool, great component, but not enough time and energy is spent figuring out what's in the OT environment and who operates and maintains them. So going on the site will give you the opportunity to talk with the operators, get an idea of what the working culture is and the insider threat level. You don't know if you don't visit a site and if there's a protest brewing and if there's unions involved, if there's operators working from home and emailing sensitive documents to themselves. You want to make sure that you're aware of those things. Mergers and acquisitions can also reveal a lot of interesting information about the health of a cyber program that you're also inheriting. So you don't want to really totally rely on the M&A team to fully understand and represent your interests here. And so a couple things you want to look for are, the current internal, external cybersecurity audit reports. You want to understand if the acquisition came with a cybersecurity stack at all. And take a look at the current and post-merger org chart for, how those cybersecurity duties are going to be dispositioned. You want to know who is quote unquote holding the bag on those cybersecurity tasks. And then you also want to take a look at the projected ownership model between the vendor and the company, because it may limit the things you can do, and we'll discuss more about this in stage 3. For vendors in procurement, OT teams typically have long-standing relationships with vendors, and it creates a certain nepotism. And this is important when you consider new cybersecurity technology. And why is that? Well, the OT staff may already be working with a vendor. You may not even know it. And so to address this, you should ensure you establish a good, solid relationship with procurement on big procurement efforts that have these cyber implications. Corporate repositories, I think a lot of us in here know that it could be a trove of a lot of information. It doesn't have to be totally accurate, right? I think if we use this as a tool, it can lead you down to POCs that are working on OT efforts, and so you want to take a look at that. And there's also other types of repositories like Documentum, specialized repositories where OT specifically relies on to conduct the day-to-day business, and so these are some questions you want to ask.
So, I see some gray hair out there, right? So I know there's at least some of you that remember a time when you could smoke on airplanes, right? And for some of you younger folks, there was a time that you could smoke on airplanes, right? So, back then there were no laws against it. Maybe there was a smoking section in the aircraft, but, we're all sealed up in the same tube, so, that smoke would travel throughout the whole airplane and affect everyone. So, as the dangers of smoking became known, smoking was eventually banned on the aircraft. And so What's interesting, though, is that, the remnant of that was the ashtrays that were left in the armrest, right? So, airlines dealt with those in different ways. Some just left them alone, some screwed them shut. As time progressed and newer aircraft were built, they were removed completely. And so what you'll find here is that over time, vulnerabilities that are discovered in your OT systems are kind of like that ashtray that's sitting there in that armrest, right? It's something that just hangs out in your environment, and can potentially be costly to deal with. This chart right here kind of shows the amount of time that the mean time really for responding to certain vulnerabilities for their different product lines, right? So this is not all inclusive, but as you can see, it can take months sometimes or longer to develop, patching for discovered vulnerabilities. And so, applications designed for industrial processes, that exist, on operating systems are built with certain libraries. And so if there's perhaps a critical OS patch that comes out, you have to wait for that vendor to upgrade their application to then run on the newer OS, right? So it's not just that the application takes a long time to develop vulnerabilities, patches for. You also have to wait if there's OS patching, if they have to make changes to the application itself. And so, in these cases, the applying patches takes more time than it would on the corporate IT machines, right? So there's a couple things to take away from this. So one, use a risk-based approach when determining what you're patching and what you're not, right? Not every vulnerability needs to be patched. You can have other mitigations or controls in place. But use a risk-based approach to determine, what really impacts your environment and which things that you really need to do. Next is, understand the kind of maintenance windows or cycles that exist within your organization, right? And try to take advantage of those, right? So if you don't have to take something out of production or offline to patch it, and you can take advantage of existing windows, that tends to make the operations folks a lot happier, right? You're not incurring any additional downtime to take care of these issues. And then lastly, if you can't patch, right, you have to determine what compensating controls or mitigations that you can put in place to address these issues. So, which leads us into, we talked about, risk-based approach to this. Well, there's a lot of different models for risk. And so in that discussion for prioritization, you'll be faced with, various perspectives of risk as well as terminology. This can become confusing when you visit sites that have very different operations. So for example, a risk discussion with perhaps the C-suite or the executives will probably be a very different discussion than with a plant manager. And so risk discussions can also be different from physical or cyber, from physical security to cybersecurity. So, and then, what's important for, what you consider important for cybersecurity, may not be important for that operations team. So it's, really establishing a common language and a common model that you can talk about these issues with. So, how does this impact you? Do you create your own risk models or do you use theirs? What's important from physical security perspective or cybersecurity perspective may not be important from a business perspective. There's other things like seasons, right? Some things may be more critical in winter than they are in summer. Or you may have one plant or process that's, doesn't run all the time, but when it does run, it's very critical. So, taking all these variances into account is essential when you determine, the risk models and then determining your overall cybersecurity risk and posture for the sites. Then leads us to risk exceptions, right? So as you go through the process of assigning the ratings, and it's not uncommon in OT that there will be many security exceptions. So what are the risk exceptions? Well, these are the things that we know about and we have chosen not to address for various reasons, right? And so there's a couple reasons why we perhaps won't choose to address these risks. And so the first one is maybe cybersecurity policy, right? Maybe there is no policy, right, that requires us to do anything about this, so we don't. Maybe the policy exists, but we've left it up to the business units or the operators to interpret that policy, and maybe they came to a different interpretation than was what it was intended. Or maybe the policy exists and we've pushed down the responsibility to those business owners to kind of develop their portion of the policy. What you'll find in those scenarios, right, is they may meet the policy to the letter, but it doesn't achieve your overall effect of what you wanted the policy to do, right? And that security gap still exists. The next thing, right, is vendors. So, there can be long lag times between when patching is available, for a vulnerability. And so you may have a vendor that's, very slow on developing patches. You may have a vendor that, or a contract with a vendor where cybersecurity and patching wasn't part of the contract. So maybe you have to go back and renegotiate it at a cost. And then lastly, maybe, there are vendors out there that are just not good at cybersecurity. And so the last and probably most common, right, is operational impact. So, if you're in an environment and you have, potentially thousands of devices, that are impacted by a vulnerability spread across multiple sites, the time and cost to remediate that might be too much, right? And so you choose to accept the risk and move on. So, the downtime required, so what can you do, right? Work with your OT teams to understand, their maintenance cycles, how replacements are done, what the cycles are, how they're funded, and start building a plan in place to work within those work management systems. Which brings us back to our good old ashtray. So, there is still one ashtray left on airplanes, and it's mandated by law. So, even though smoking is banned, entirely banned on all aircraft, it exists, and it exists because it's there for passenger safety, right? In case somebody does break the rule and they have to put out, a cigarette or something like that. So, you can consider that kind of the exception there.
The third stage is policy and equipping, and here where we're identifying solutions, whether it's policy, procedure, or technical measures. And it's important in this stage that you don't trivialize the solutions, thinking that what you've done in the past will work in the future. Everybody's different. And you also need to be discerning about the products and services in the marketplace and what will be most impactful for the OT environment at the time you're going to be delivering it. So simply bombarding your OT staff with a lot of tools and processes without understanding their needs is just going to stall your efforts to support them. So once we prioritize all the findings and built our plan out, we start addressing the gaps. And here we can do this by using the NIST CSF. There's other models, as you would know. There's not enough time to go into everything in detail, but we'll cover some common themes across various industrial sectors that you may face when equipping your program. In the identified category, we are asking ourselves two basic questions. What do I have, and is it targeted? And there's typically a lot of invested in threat intelligence, and there's a lot of great programs to provide you good information both federally and commercially. The challenge with that is that you might end up spending almost 2/3 of your time trying to hunt down all the different types of assets that are affected by a particular vulnerability. And aside from having limited visibility to the networks that are connected, it's not uncommon to observe a number of systems or subsystems that are islanded or just not connected to the network. So there needs to be more time and investment in mapping out your networks. There's tools, a lot of vendors here like Red Seal that can help accomplish the task. The protect category may be one of the more complex areas since you're really layering your defenses at this stage and requires significant interaction with various stakeholders in IT, OT, physical security, et cetera. There's a lot of great security products available to help protect your OT assets, but I think the most undervalued, cost-effective, and underutilized tool, in my experience, is just training the OT staff. And I'm just talking about basic cybersecurity hygiene and discipline. There's a recent Gartner report out there that says 69% of employees have bypassed their organization's cybersecurity guidance in the last 12 months. Another statistic out there from that report is that 74% of employees said they would be willing to bypass cybersecurity guidance if it helped them or their team achieve a business objective. So no matter how well defended you are, don't neglect the training aspect for your OT staff. Security event monitoring tools for OT environments are maturing, and I'm really excited to see some of the innovation in this space that will improve detection and reduce operator fatigue. One report suggests that on just the enterprise alone, an average of 174,000 alerts and notifications per week are managed, and less than 40% of that data is triaged. So you need to consider this for an already overworked SOC staff when you look at detection tools. It needs to aid in the automation and integration with the existing tools where possible. And watch for blind spots. Modems in industrial environments are notorious for misconfigurations and often discoverable in showdown, so you need to set up alerts to watch for unusual spikes in utilization. The respond category is one where you can foster the most engagement with your OT partners, and We have a tendency to think just the reactive pieces in this category, but there is a proactive component of response. And as part of your OT response plan, like we discussed before, you also want to create the external partnerships with CISA, FBI, and your ISAC, your respective ISAC. The ESCC, the Electric Sector Coordination Council, also has a great program for cyber mutual assistance if you're in the power and natural gas industry, and I think this is something that I think should be modeled for the rail industry. The other component is about maximizing the effectiveness of your IR retainer. So whoever is doing this for you needs to know your OT environment in advance. We might spend a lot of this time at the onboarding of our retainer, but they need to be informed of major architectural changes that occur as well as the mergers and acquisitions. In the recover phase, I do want to point out insurance and backup and recovery. If there's damage to equipment, you could be expected to support an investigation team, which might involve insurance agencies. And you need to verify if your cyber insurance policy covers your OT environment. And even if you are covered, you need to check for specific exclusions so you can address those. And if you don't have any cyber insurance, then be aware insurance rates are going up. There's one report noted that an increase of 25% per quarter in cyber insurance rates and a decrease in coverage. For backup recovery, for most large companies, they design systems in such a way that it is resilient when there's an event. However, you need to test the failover and document the results of that test. And this is especially necessary for third parties operating equipment on your behalf. For other companies that are smaller, one attack can shut the company down, and only 14% of those in this category are actually prepared for this incident. So we talked about things to look for when equipping for the OT environment. However, you may be limited in what you can actually do. So let's talk about the different kinds of ownership models when it comes to OT, because it affects how you provide incident response, architecture, and engineering. In each of the 4 models we discussed, we're talking about how to protect company OT data and what kind of control, visibility, and transparency you'll experience when building it out. The simplest ownership model is one where the company owns and operates the OT equipment, and here you have the most internal control to accomplish security objectives. And in this case, you can deploy your technology and policies relatively freely. You can achieve the most insight under this model and adapt to changes as they occur. And then when an incident happens, you can start investigations early and have better transparency throughout. Another model you might observe and is one where the company owns a portion of the equipment, but the vendor operates the equipment. Some solar farms can be observed under this kind of model where the vendor's infrastructure is intermingled with the company's. You have control over the equipment you own at the site, but you rely on that vendor to uphold the security practices in your contract. And you have partial visibility under this model. The other 2 models are more common when you look under the hood. One is where the vendor owns the OT equipment but is operated by the company employees. One example is where a company purchases energy from a wind farm. The wind farm and the maintenance belongs to the supplier, but the people that operate and monitor that wind farm are company employees. In another couple use cases as well, with respect to maybe business aviation, you may have company pilots and maintainers, but the engineering changes need to get approved through the supplier. And the same could be for trains. You have conductors and engineers, but all those changes go back to the supplier. So it can be one of the most complex arrangements to work in terms of incident response, engineering, and architecture design. And making changes to the infrastructure and procedures, it'll involve legal or contracting teams. The 4th model to discuss is where you have the least control and security visibility, and that is where the vendor owns and operates the OT equipment on behalf of the company. And under this model, the vendor is what could be slower to respond to your requests, and you have the least transparency when it comes to threats and incidents. The point is, for each of these models, you have an inherent level of community risk, and that is risk the company and the vendor share. So it's wise to go through all your contracts and identify which box they fit in. Another thing you want to take into consideration here is where you're at in the life cycle of the system, where the gaps are you're trying to close. And so if you assess a system in the commissioning phase, you might be one of 100 other people trying to complete different testing objectives. And so what you'll see is potentially a lot of temporary connections as they commission the plant. You might want to consider coming in toward the tail end of that discussion, or at the tail end of that commissioning phase and most of the design discussions, and do the testing when the system is a little more stable. For sites that are acquired as part of mergers and acquisitions, continuity might be a concern, and you might be lucky to catch the person that managed the firewall before they left the company. You might see dangling hubs and switches connected to unknown networks with no plant knowledge on what it does, and people are too afraid to touch it outside the plant maintenance window. And this is typical when plants are sold, and bought again. What about sites that are soon going to be decommissioned or divested? Well, you might think you would just wipe all the data, but there are cases where you must maintain the PLC logic for it to be operational, but remove the sensitive data. In other words, you can't brick the system such that the operation doesn't work when you divest it. Another big issue that you probably should be concerned about is those kinds of projects that are in the pilot testing stage. And why is this? Well, pilot projects that require some level of corporate connectivity are typically not in a secure state when piloted. And it can be viewed as a way to circumvent the full rigor of a cyber assessment and security controls. And in essence, it just remains active in production indefinitely until and sometimes unnoticed. So when you onboard new systems, take care to scrutinize these kinds of projects.
All right, that leads us into tooling. All right, so some helpful points when considering new technology and policies. There's value in leveraging requests for information out to industry, right? This is an opportunity to drive evolution and maturity in product offerings and use cases, right? So, I'm sure everybody here, right, we all have our favorite vendors. We all have the things we like to use in our environments, right? But don't let that blind you to all the new and upcoming technology that's being introduced in this area. So another thing you can do, right, is partner with like CISA and the national labs. So they have done a lot of research and a lot of work in critical infrastructure and cybersecurity, and they are more than willing to talk to you and help you out if you have questions or concerns about things within your industry. And then lastly, focusing on automation and integration. One of the ways to deal with minimal staffing or low staffing requirements, right, is to automate where you can, right? Where we can automate, we might not need as many, staff to help do this. And then, be aware that most of the performance work to operate or maintain a tool you select may come from a small set of OT personnel, right? So don't write a policy or drive technology that your OT staff cannot support, right? Involve them in the process to make sure that, they have the resourcing requirements that they need. So in testing, you want to be able to give confidence to, to your business units, right? And what you're recommending deploying will not impact their operations. So having a capability to test is critical to develop and deploy security baselines and capabilities. You have a number of testing methods to consider, ranging from building your own testing labs and facilities, or to outsource that testing to vendors or third-party companies. Right? Building a dedicated capability can give you the most control and flexibility for your testing, and it doesn't necessarily have to be the most expensive, right? You can be creative in how you do these things and introduce at least some capability in your environment at a lower cost than you might think. The further you move right on the line, it starts to get potentially cheaper to test, but you're going to have less availability and access to devices that you want to test. So consider the range of options you have when it comes to time to test. You may find that most vendors will work with you when you bring them test cases on how you want to do some of their products. And then the ultimate goal of testing is to safely deploy and securely configure products in our OT environment. So this can be a big task, especially for larger organizations, for a few reasons. So you may have hundreds of different devices, and of those devices, each of those devices can have different configuration settings. From those configuration settings can vary across, different firmware versions or software versions on those devices. So in those cases, CIS benchmarks may be helpful in some cases, but generally you're going to be referring to the manuals for any security capabilities that they provide. Some of the newer security, some of the newer devices that are hitting the market, they actually do have security options built in. You may not see them configured in production, but they may exist. The legacy stuff, again, was designed mostly without security in mind, and so those are where you really have to work your mitigations in to secure those systems. But the key is to document and publish standards in a library that your OT staff can reference, so they can start to implement some of these changes. Right? They may not be able to do all of them, but you will at least be able to engage with them and work on certain mitigations that you can actually implement.
So we covered a lot of areas, and no matter where you're at in the development of the program, you can apply these principles to get you on the right track. And discovery can be one cabin at a time, one network at a time, one site at a time. And dispositioning these findings is not just about prioritizing the most critical issues, but the most systemic issues that can help drive cost-effective solutions. And when you think about applying solutions in the form of policy or technology, check in with your OT customers to get an agreement on the approach. You want to make sure you understand the constraints you're operating within, given the vendor company ownership model and where you're at within the OT lifecycle. When you reach a point of remediation, ensure the technology you select and policies you create will scale, they'll integrate and automate in a manner where it can be digested by the OT staff. Because if you do too much too soon, the rollout can be slow or just flat out rejected by the OT community that you serve. You need to create an environment where the OT staff trusts the testing processes you put in place so that they can be deployed, so that they can deploy the security baselines. And when you gain traction from this after the first time you go through this process, you should start to notice it goes by a little more effectively with increased trust and cooperation. So we presented a lot of material here, but you can find additional information at the link below this community resource, and encourage you all to contribute. I think a copy of this presentation will be posted to the RSA website. And at this time, I think we can open it up for questions. I think we have some time, right? Perfect. We have 9 minutes for questions, and so looks like we have someone here that wants to step up to the mic. If you do have a question, please step up to the mic. Thank you.
Previously, I used to work in the medical and HIPAA security world, and NEMA worked with HIMSS to develop the MDS squared cybersecurity checklist form, where all medical device manufacturers created a checklist form that talked about the cybersecurity aspect of the medical device. Is there other efforts in NEMA that you're aware of for different classes of things like PLCs or controllers that do the same thing as the MDS squared form? And I have another follow-up question about disposal of devices. What type of what type of legal actions do you need to do when you dispose or sell devices to make sure they're safe and secure?
So I know it's a healthcare question, a healthcare system question. I don't have much experience on that side of the house, but
Yeah, not in healthcare, but doing something similar for
sure.
operational devices.
And I don't know too much about that framework you're talking about, but there are a lot of different frameworks on the electric sector, the pipeline, C2M2. If you're talking about a maturity model, I guess I'm not quite sure to where to go with
I think
that.
what you'll find, right, is in like NERC and SIP, right, is I think where you would find things like you're speaking to, right, where there's checklists or device configurations for controllers or things like that. Yeah, so those do exist. It depends on the industry that they're in. Some industries may have more, some industries may have less, but it does exist out there. But again, it's going to be a little more industry specific.
For your SOC area, do you have specific incident response plans or playbooks for the OT incidents, or is it all combined?
I'm sorry, can
No, I've got it, yeah. So the answer is yes. So we have our IT playbooks, right, for incident response, and we do have OT-specific playbooks for incident response. Okay. Due to the nature of those systems, right, you can't necessarily apply the IT ones to the OT ones. So if you haven't already, I would highly recommend developing those playbooks and responses for your OT systems.
But operated by the same SOC?
So there's two different trains of thought on this, right? So some people like to have split SOCs where you have one dedicated to the IT side and one dedicated to the OT side. And then you have some that combine SOCs into one, right? And so, you know, I've seen it done both ways. I will say that when you have a combined SOC, you do need to have a dedicated team within that combined SOC that focuses solely on OT matters.
Thank you.
Hi, Oliver from AGL Energy in Australia. Great preso. Dreaded word, budget. So one of the challenges I have is, you know, the cyber budget will go up against OT budget. So refitting a turbine versus implementing security controls. Have you got any examples of how you've navigated that?
So, you know, I think really what it takes, right, is leadership buy-in, right? So we've made cases, you know, to the board and to the executives, and it's really demonstrating, you know, demonstrate what the risk is and demonstrate what the potential loss is, right? If you're able to, you know, articulate that, hey, not addressing this potential cyber concern can lead to, you know, this amount of loss, you can tend to get their attention.
Yeah, the trouble is they'll say turbine maintenance and big impact, cyber impact, low risk, but big impact. So you're playing that balancing act. So.
And then unfortunately, in a lot of cases, right, you find that you get the funding after an incident.
Yeah,
right?
sure.
So when something bad happens, they tend to be a lot more receptive to providing funding to address those issues. And so, you know, I've always been a proponent of, you know, an old saying, right? Like a smart man learns from their mistakes, a wise man learns from others. And so it may be worth illustrating other cases within your industry where things like that have happened and the potential consequences of when they happened. You know, just because they haven't happened to you doesn't mean they haven't happened elsewhere. And if you can, sometimes you can paint that picture and say, this could be us because we have these same vulnerabilities or concerns, that might make them, you know, be a little more
That's good.
receptive.
Yeah, cool, thanks.
Okay, any other questions? All right, well, thank you everyone for your time.